When we talk about site work, there may be a lot of new terms that you're learning. So take a look at that chapter and look at the diagrams for some of the things that we're covering. I am going to post this PowerPoint that is kind of a review of the different slides and information that you would see in the book. So, for instance, these slides will talk to you about the surveyor and GPS, along with what a match line is, elevations, spot elevations, contour lines, test borings, like soil borings for the strength of the soil and the capacity there, catch basins, silt fences, and what all of these things are, detention pond. So there is a difference between a retention and a detention pond that we'll take a look at in a minute. So this is the book information that's talking to you about the plant schedule, and some of those things are questions that are at the end of the chapter that you'll be answering. So take a look at this PowerPoint and the different slides. Each one of these slides has notes. So for instance, when we're talking about LEED certification, when you look underneath here, you'll see that there is a little more information about it here. We are talking about leadership and energy and environmental design. But you can see already that some of these details are some of the details that are in the chapter. I did put together another PowerPoint that will give you more graphics for some of the information. I actually taught a construction company how to read surveying civil drawings, which are normally start with the letter C. So let's go take a look at this example when we talk about grading plans. This is a Marathon Station, and we'll be taking a look at what some of these elevations mean. So there's a concrete pad, and I just wanted to show you here that there's a dash line that's inside this concrete slab, and that would be where this foundation thickens, and that's called a thickened slab. So these are additional terms, but also terms that you'll need to know in our field and a part of that chapter. Sometimes an elevation, a spot elevation, will have letters that are next to it, like TP for top of pavement, or top of curb, TC, or slab. And you'll see that there is a definition for a bollard. That's what these are. They're basically metal posts that keep people from damaging the curb. So as you look through this PowerPoint, I'm going to post it for your information. Some of the things that we're talking about are right here. So you see a photo of the actual curb and some of the pieces over here. You'll see that as we continue, there are spot elevations, and there's the drawing of it. The drawing of the curb is right here, and here's the concrete slab, and then these are the tanks. Okay, so in this slide, you'll see that some of these words are words that you found in chapter 3, like a dry well, a swale. We'll take a better look at the rim elevation, but can you see that these are all on drawings that you'll see when you start to look at construction drawings? We're going to be taking a look at that a little bit later on also. There is a finished floor elevation, FFE, which is kind of a known elevation that sometimes is what we start with. The surveyor has an elevation, and so does the building itself. So we'll take a look at how those two relate. Contour lines we looked at, and that's what this slide is about. I put this together to kind of show you, to make it simple, but these kind of images are also in chapter 3 on site work. So take a look at that chapter. You can see here that when these contour lines are really close together, you're going to have a steep slope, and when they're spread out, then the ground doesn't change in elevation very, very rapidly. And here's kind of a cut through of what these numbers represent. You see the higher numbers, and then we're going down to the lower numbers here. They're usually 1 foot intervals. Sometimes at 5 feet you'll see that they're bolder, because on larger projects the 1 foot is not as important as the 5 feet. We do have existing and new, and so when you have the existing contours and you're showing where there's cut and fill, so you're taking dirt out and you're filling it, then the existing lines, elevation lines, are lighter than the new ones. This is a catch basin, and what it looks like, it's pretty much a place where the water can be retained and then slowly drain off through this drain line here. And we're talking about the rim elevation we talked about, and the invert elevation, which is really the top of the bottom. Let's see, here's a diagram about it. So here's the rim. The rim is at the very top of it, and you'll see in your drawing there that there's the word rim, and then there's an elevation number right there, or a manhole, MH, right there. So the way that contours are set up, there's a high point and there's a low point, and usually the high point then kind of drains down to the catch basin here in the parking lot and drains down away from the concrete slab here. See that? So here's that invert elevation, which is defined as the inside elevation of the bottom of the inside flow line pipe. So you can see on the drawings that we'll be taking a look at where those CBs are, those catch basins, and the elevations or the slope of the ground will get lower so that it drains to it. A dry well is kind of what it sounds like. It's going to pick up some of that surface runoff, storm water. We want to make sure that it stays on the site as much as we can, so that the water doesn't run off into the lakes. So we create material that's porous, or material that the water can go through into the ground. And drywall is a good example of the water draining to it and coming out through these perforations here. I do want to mention here that recently there is porous concrete and also asphalt, so that water can go through and into the ground. The Detroit Zoo has a whole parking lot on the Woodward side, right there on the north side over there by Woodward, that's all like a porous asphalt paving where the water goes through instead of run off, which is pretty exciting. It wasn't as strong for the concrete, so they're working on it for more applications. Hey, here's the swale. A swale is really a part of the land that is sloping down and away from the building. So you'll see the lines will kind of curve in, but you can see there's the high point and then the low point, so that you can see the arrows kind of sloping down the water. So when you look at a site plan, when you look at the contours, you can kind of get a feel for how the land is laid out. We're talking here in this slide about the finished grade and the percentage of the change of distance. So we have this kind of triangle where there's a run and a rise and a slope. So when you look at it, the slope is equal to rise over run, and if you do a little bit of math, you'll see that the run is equal to rise over slope. And then down here, this is the one that you're looking for the question at the end of the chapter. Rise is then equal to slope times run. Now remember, this is feet, so we're talking about the run is 50 feet. In this example, the slope is 0.02, so the rise is 1 foot. Okay, so when you look at a site plan and you see all these contour lines, sometimes you'll see arrows that are showing what that percentage is. I put in some typical here percentages for drainage of yards. When we look at a laser level or a surveying, tripod here, and the level rod, it's kind of it seems like a complex topic, but when you really break it down, we start off with a known elevation like the finished floor. There's 100 feet. Then we measure how high it is from the finished floor to the top of the level. And then taking the top of the level over, you can then project how far it is from the rod here to the elevation. So you take here the 100 feet, you add the 3 feet, you subtract the 7, and you end up with 96 at this point. And this is kind of basics of being able to use here surveying benchmarks and to figure out elevations. There's another example, or actually the same one but at different numbers. So the grade rod has these numbers that are set up by decimal. So between the 2 and the 3, there's a 0.9, 0.8. So it's 2.9, 2.8, the way that this rod is. And when you take the surveying class, I'm sure you'll go through some of that. I just wanted to point that out. This was detailed for this company that I showed. On the other side of the grade rod is measurement for height. So a lot of people don't know that or use it, but if you turn it around, you can, if you're in a lower ditch like this, you can use the back of the rod or the grade or leveling rod to find out the height of your excavation. Here are other photos of that concrete pad. The difference between a retention pond and a detention pond, you'll see this on the drawing. It looks like kind of like circles of contour lines because the numbers are going down to a low point. So a retention pond is meant to be a pool of water that holds stormwater runoff, and it's maintained as a pool of water throughout the year. Detention ponds are only temporary and usually don't have water, in them because the water drains. So you'll see these on the site plan. They look similar, but they're called a little bit something different in the way that they're drained. The monitoring well is going to help us to monitor the water quality around hazardous materials. A silt fence, you'll see that in the chapter. Just wanted to show you here on these drawings the outline for it. It's also called a filter fence, and it holds back, it's temporarily holds back or controls some of that water runoff. When during construction there's a lot of loose dirt or a lot of contaminants in and around the job site. We don't want that to run off the site, so we'll use this kind of fence, sometimes bales of hay, to stop the water from running off. Sometimes they use what they call a sock, which is really just a tube of material that's weighted down to stop the water or control it. I wanted to show you that there are sleeves that are used, irrigation sleeves made of PVC, so that water can be pulled from one area to another. And also we use those when we go through concrete with caulking around it here in this detail. And here's another detail to show that. Okay. Trench drains, you'll see those quite a lot. So the water comes down into the trench drain and kind of sits there, sometimes continues on to be drained, but for the most part is for kind of temporary hold the water. And there's some talk in the chapter also about utilities lines, so W for the water, G for the natural gas line, and some other ones like the electrical line. You'll see those on the drawings, and there's usually a legend that talks to you about what each one of those little symbols means. So when you first look at site plans and grading plans, they look kind of overwhelming until you start to break down all of these terms that you're learning and kind of understand what these little lines represent. So we know we have elevations and we have slopes, and there's kind of a makeup and usually a detail that shows the different layers, the compacted fill that's underneath that holds the ground solid. Okay, there are ways of creating with crushed rock this kind of drainage that we need for the site. Rock ledges and retaining walls that hold the dirt back so that we can kind of force it to drain a certain way, and two different vegetation. Identifying your different soils. There's a chart in the chapter also that's very similar to this. When we look at those four major groups, we have clay, silt, sand, gravel, and even boulders. So more than four, but they're determined by how big the grain is, the particle. So greater than 3 inches is considered a boulder. But here are some of the ways that you'll see that type of soil on the site plan. And other terms I've added in here, like the geotextiles that we saw in the chapter. Here are the sheets or the rolls of the material that stabilizes the earth to avoid soil erosion and kind of protect the vegetation here. I included a couple of other terms here, and then the cleanouts. We'll see these a little bit more when we look at mechanical drawings. Okay, the drawings that go with the questions about site work are really from a project called SIRTI, S-I-R-T-I, and you probably have the hard copy of it. I have the digital form so that I can work with you a little bit. These would be sheets 3 through 8. So if you look at your drawings and you open them up, on the side of it, see you see sheet 3. So sheet 3 is on one side, and then sheet 4 is on the other side. And if you look at each one of these sheets, you start to see what they are. So sheet 3 is the site plan, and the site plan is C1.1. So when you look at the site plan, you'll see that there's the parking lot, the building right here, the property line, some of these things like the temporary construction fence that only goes around the front part of the property and not the whole thing. But if you look at this, there's a river on the left-hand side here. So look at your drawings and kind of take a look at what the elements are on that site plan to familiarize yourself with them. You'll see that there's a cooling tower here and some parking, handicap parking lots right there. And the water's draining here towards the river in some cases. So this is the site plan. And if you look at sheet number 4, we have the site topo or topography, and there's a legend, just like we talked about. You can look at the different symbols and kind of pick them up to look at like utilities and things that you might be asked questions in the set of questions that are coming next week. You can work on those this week to get them done if you'd like. You'll see that there's a 5-foot utility easement here, and here's that River Point Boulevard. The thing about this drawing is this is a drawing of the existing land without the building on it. So there's the true north, and the whole thing is rotated differently. It comes from a different it comes from the surveyor, so you'll have drawings that are coming from the surveyor, some that the architects or construction company works with, and it depends on what kind of information that you're looking for. But this is all about just the site itself. You can tell that there's the contour lines there, the waste material or the dump area, some rock formations, and then this is the river. So watch out for this, because you can see that the whole thing is rotated on the site plan. The river is on the left side right here. On the topography plan it's up at the top there. Okay, sheet number 5 has the grading, and where are we at? It's kind of a layout of the building and a few details. You'll see that the building's true north is to the left. You'll see where the catch basins are. There's small little boxes right there in the corners of the parking lot. And if you look at the contour lines, they slope to those catch basins. Take a look at this typical parking space dimension. Some of this is kind of hard to see, but you have to kind of get close to it. You have the drawings, so you might be able to see it clearer. There's the parking dimensions right there. But these are drains, so catch basins with natural runoff drain to the rivers, and rock formation along this this river. This being the building itself with a sidewalk around it. You can kind of imagine that here's the main road with the driveway coming in this way. But one of the things I wanted to point out to you in this drawing is that there are a lot of details. So if you see a detail that says, like, for instance, 25 or 26, and then underneath it says L1.8, we're talking about looking at number 25 on L1.8. So let's go over to sheet 8. These are all the details. So that detail of the curb is number 25 right there. So if we look at the plan, whatever the plan is, you'll see that these kind of section cuts go through and show you what you're seeing in an enlarged section. So this is 23 on L1.8. If I go over to sheet 8, which is L1.8, and I get a little closer, I go down here to 23, you can see that this is the section that's showing you the bottom of that drain where it comes out. It comes out from the slope and towards the river. And here's a plan and a section. So going back here to this layout, each one of these drawings represents a different part of the site, of the same thing, the same site, but one will be just grading, the other one will be the topography, this one is this, and then the site plan. This one shows kind of the layout with dimensions. So you'll find dimensions of the typical parking and some other dimensions of how far it is from the property line to the building, that kind of thing. And here's a legend showing you what we talked about before. So sheet number 6, let's go back a little. You can really see right away has a lot of contour lines. So the other one was the existing contour lines. This one is a grading plan. The grading plan will show those contours a little bit more detailed around the building. So you can see that it starts off higher at the building wall right there and kind of slopes down so the water runs away from it. And then we said that contour lines that are close together are going to be steep. So the ground over here by the river is pretty steep compared to the ground over here that's kind of opened up a little bit more. Okay, you can see there's your CB for catch basins, and let's see, I'm thinking about all the questions that are asked there. Spot elevations. Here's catch basin number 5. That's one of the questions there. Catch basin number 5. It drains over towards these rocks here. It looks like it drains to catch basin number 6, but the idea is that it drains to the rocks and kind of goes through those rocks, the water. And then catch basin 6 takes all the water from this kind of swale that the water's coming down through. Okay, that's sheet number 5 or 6, and then sheet number 7, irrigation. Irrigation plan is showing, how all of the water is coming to the site and moving around in the site to water the grass and the plants in that area. And you can see that there are sleeves where it comes through. Typically on a lot of these sheets you'll see a legend and notes, and in this case there's actually a diagram of the different valve system that's in place. So you might find some of the information here in these notes, but not specifically on the drawing. Okay. Same site, just a little different information. I like these type of scales here. Sometimes the scale is represented by a number, like an inch equals 30 feet. But if you draw one of these graphic scales, then the drawing itself can be enlarged and reduced in size, and you still have a pretty good idea of how far it is from 0 to 30 feet right there without using a scale. So it's a great way to keep track of the scale even if the drawing gets enlarged or reduced. All right, and then sheet number 8 is the one that has all those details. If you really look at these details, we're talking about the catch basin, just like in the PowerPoint I showed you, some planting areas, a foundation here to give you some typical dimensions on where the landscape fill is. And then We have a curb ramp. Usually it shows kind of the slope of it, the stone detail, and a few other things like a bench actually detail. Here's the front view, and then here's the side view there. So as you look at these a little bit more, you kind of understand or start to understand that most of these are in section, and it might say it right there in the title. So this would be sheet number 8. So when you look at the questions, and I have the questions in front of me now, you might look at a question that says River Point Boulevard is 100 feet wide. Well, you're probably not going to find that on the detail sheet. So you go back and you take a look. Does it show River Point Boulevard dimensions here? No. I mean, do you see them here? I mean, yeah, there's something right here that shows the dimensions. So look around the drawings, find out where those things are. There are 60 questions. You don't have to answer all 60 of them. I'm going to post that you can pick 25 of these 60 questions to answer. So go through them, look at these 6 or 7 sheets, 6 sheets. It's only 6 sheets 3 through 8. And some of them are asking like the size of the typical parking space. Well, we saw that on the layout and dimension plan. Maybe asking how many drains there are, catch basin, drains, or fire hydrants. Take a look at some of these questions that talk about the width of the sidewalk, or the gravel base, which is, when you think about it, a detail, right? So when it's asking the gravel base under curb ramps is so much thick, you would probably get that on the details. So take a look. One of them even asks about the rim elevation of catch basin number 4. So you have the drawings to look through. I think the idea behind these projects is for you to look at the drawings, keep your kind of face in them to understand what's going on. It takes a little bit of practice, but I think understanding that you have some plans in place that have specific details, or specific items on them, and then details here. So each one of these details has a number, and you'll see that number on whatever sheet these are on. Sheet number 5 has most of them right here. Okay, so keep in touch with me if you have any questions. I can go through some of these afterwards, but I'd like to give you guys a chance to take a look at sheets here 3 through 8 and answer at least 25 of the 60 questions, so you can choose from those. Now we're talking about, there's a difference between the review questions, which are like the chapter questions, and the trade competency test, they're calling it, which is really referring to the sheets. So you'll see at the top of the questions it says refer to this project, whatever project this is, and here these are the sheets. Okay, keep in touch, and there's a lot of great information here about site plans as we work through the different construction drawings that you'll be taking a look at.